Hey guys, so the other day, yesterday, you watched the video on the steps to solving equations. Today, I want to do some of these problems so you get a chance to see some more being done. And remember, use on Delta Math in the problem section, use as well the videos that are built into those specific problems because sometimes those will be more specific. So in class today, we did mostly problems that were just one step. It would have been like, I'm going to cover this up, 3x equals -6. And you were just doing one step. Divide by 3, you were done. So I want to look at some more, just a couple basic ones there that are 2 to 3 steppers, but then ones that are also multi-step as far as variables on both sides. And then everybody's favorite, fractions. I know you all love fractions. So I'm just going to go through with these, talk through the steps. And again, don't be afraid to pause, write down additional things that I say, but maybe don't specifically write down. So with each of these with our equal sign, I'm going to draw that line down there to separate one side from the next. Now, I still have up here, and hopefully you have near you your notes, what are those steps to solving equations? So if there's parentheses, distribute. Number 2, combine like terms on each side of the equation. Number 3, if variables on both sides, add or subtract the smaller 2 variables. We'll definitely see some of those today. Isolate the term for number 4 with the variable by adding or subtracting the constant. And then 5th, multiply or divide to get the variable alone. So in this one, I don't have parentheses. I don't have variables on both sides. I'm just trying to isolate here by adding 24 to both sides. So notice as well, this is the visual part of it. It's lined up nicely. 3x drops down. You want a visual cue, draw the arrow. 24 cancels out. Equal sign is here on that line. -6 plus 24 gives me 18. And I want to isolate, you don't have to circle the x, I'm doing so here just for the notes. I want to get that x all by itself. Well, how are the 3 and the x attached? Multiplication. Opposite of multiply is divide. So I get x is equal to 6. Want to double check? Plug them back in. Okay, 6 times 3 is 18. 18 minus 24 is -6. All right, this one I specifically put on here because sometimes you start with a giant fraction and divide. In this case, I want to get rid of it right away. How do I get rid of it right away? I multiply both sides by 3. Now, the right side is actually usually the side that people are good with, 11 times 3. This is the side we struggle with because this is really like 3 over 1 times 4x plus 1 over 3. Well, what happens, and it's not magic or math magic, the 3's cancel each other out. Don't distribute this through and then divide by 3. You're just going to end up with 4x plus 1. So the shorter way is just to say, all right, I have a 3 divided by 3. That's like 1. Well, 1 times anything is anything. This case, anything is 4x plus 1. So now it looks just like this problem. So if you start with a big fraction, meaning you have something in the numerator and then something in the denominator that's just a single term, multiply both sides by that term. It gets rid of it on the side that you started with. The other side, you just do the arithmetic. Now I could isolate by adding or subtracting. Here, since it's plus 1, I do the opposite, -1. So I get 4x is equal to 32. I want to get that x all by itself. The 4 is attached by multiplication, so I divide by 4, and I get x is equal to 8. Okay. Next one we got. This is one now where I have more steps involved. I'm going to use almost all my steps, I think. Specifically chose this one because of this, the -2. Step 1 tells us that if you have parentheses, distribute first. Well, the key with this one is the 3x comes down, but I am distributing a -2. So I get -2x minus 6 because I have -2 times x is -2x. -2 times 3 is -6. So I don't just distribute like the 2 and say, oh, I get 2x plus 6. No, the sign goes with it. Now, on the other side, I just have 5 minus 2x. Okay, I'm going one step at a time. So my next step would be I have like terms. Remember, like terms only apply to one side of that line. So 3x minus 2x is like 1x. If you want to put the 1 in there, you can. Minus 6 equals 5 minus 2x. Everything else is dropping down. Now, my hint to you was when you have variables on both sides like we do here, move the smaller of the two terms. So if I look at the two terms, I have 1x and I have negative 2x. Negative 2 is smaller. I'm going to move this one by doing the opposite. Opposite of negative 2 is add 2x. So I do that to both sides and I line up those like terms. Same variable, same exponent. Those don't change. This is still x. I just do the coefficients. 1 plus 2 is 3x. Minus 6 equals 5. Negative 2x plus 2x is gone. So what it does by moving the smaller of the two variables is it allows this to be a positive term. If you subtracted 1x from both sides, you're going to get the same answer. You're just going to end up dividing by a negative at the end. I try to limit that so it limits mistakes. All right, from here, I want to get the term with the x on a side by itself. So I need to get rid of the minus 6. Opposite operation is addition. So I get 3x equals 5 plus 6 is 11. I divide by 3. This is not an uh-oh. Fractions are okay. So I get x is equal to, and just kind of box these off, 1/3. Or 11/3, sorry. I can also make this, if you want, into, let's see, it'd be 3 2/3, but I don't want to write the decimal answer. Decimal answers, especially this one, it'd be 3.6 repeated. If you wrote 3.6, you'd be wrong. You wrote 3.67, you'd be wrong. If you wrote 3.6666667, because your calculator will round that last number, wrong. We would have to write 3.6 with a line over it. That's why we leave it as a fraction. Then you don't have to worry about that part. All right. Next one. Another one with variables on both sides. This case, no parentheses, no like terms to combine. Okay, be careful again. 5x plus 8 is one side. Like terms? No way. 3x minus 3. Any like terms over there? No. So I start with moving the smaller of the two variables since I have them on both sides. So over here, 5x minus 3x is 2x plus 8. Here I subtracted 3x because that's the opposite of positive 3x equals negative 3 now. Want to isolate this whole term. So in order to do so, I need to do the opposite of positive 8, which is negative 8. So I get 2x equals negative 11. Last part. Get that x by itself, so I'm going to divide since those are attached by multiplying. Opposite is division. I get negative 11 over 2. That's simplified. 2 does not go into 11. Or I could write this as negative 5 1/2. And circle the other answer. Get used to circling answers as well. Okay, voila. All right, last two. I know you're going to be excited. If you want to, I would try these on your own first, but you could go right after, or you could watch me first and then try it after you've written the notes down too. But it's everybody's favorite, fractions. Yay! Okay. Here's my trick with fractions. Most of you hate fractions. I know that. So my trick is to get rid of the fractions. But how? Okay, you can't just say, well, 3, 5, and 5, you're gone. I'm going to make you disappear. Here's the simple step to make it. You need to find the least common multiple. So the least common multiple is the number that these numbers all divide into. So in this case, for 3 and 5, because this is a 5 too, so my denominators are 3, 5, and 5. Okay, the least common multiple is 15. How do I know? Well, the smallest factors are 3 and 5. That's all the factors in there. So 15 would be the number, the smallest number that divides into all of these. Now, what do I do with that? I multiply each one of these terms by the least common multiple. Now you're like, oh, I got to multiply fractions. No, not really. I specifically picked this number because they're going to simplify. So you could do here if you want 15 times 2 is 30 divided by 3 is 10. Oh, that works nicely. 15 times 1 is 15 divided by 5 is 3. So that turns into plus 3. Here is my equal sign. 15 times 4 is 60. 60 divided by 5 is, to think this one out, 4, 8, 12. Okay, and you could use your calculator for that if you want. So now look at what I have mathematically created. Mathemagic is real too. An equation with a single line and no fractions. That's my goal when I do it that way. Could you do it by subtracting 1/5 at the start and everything? Yes. The hard part with these is you're like, well, can I make them all into decimals? I get that a lot. Yeah, not really, because this is 2/3. It's a repeating decimal. You can't do it. So that's my way to do it. If you want to still just work with the fractions in there, that's okay too. I am not someone, even though I gave you steps yesterday, those are the steps that usually work best for everyone. If you have a way that works for you and it works and you can show me the work of how you did it, I'm fine with that way. It's okay. I am not you must use my way. If you do not use my way, you do not get credit. No, if you could get the right answer and show me how, perfectly fine with me. All right, let's finish this one out. I now want to isolate the 10x, so I have to get rid of the plus 3, so I subtract 3. So I get 10x equals 9. I divide everything by 10. That's my answer. Okay, 10 ninths, or 9 tenths. I was looking at the 10 first there. 9 tenths. Doesn't simplify. Sometimes in these fraction problems, you get a fraction answer. Sometimes you don't. Okay? It's like the old commercial. It's like sometimes I feel like a nut. Sometimes I don't. I think it was for Almond Joy. Wife, Almond Joy. She's in the background. She agrees. I hate Almond Joy because it's got coconut in it. Blah. My wife has a name too. I don't call her wife, but... All right. Another fraction one, and I'm going to get rid of the fraction again here. So this one I have 4, 6, 3, and 4. So I'm going to write the least common multiple. And I'm going to look, the commons here are 3, 6, and 4. So some of you might be able to look and say, oh, well, I know what number I could divide all those into and say, oh, it's 12. Sure. Some people will be like, well, I know 4 times 6 is 24. 3 goes into 24. 4 goes into 24. That's fine. That's not your least common multiple, but it will work. And that's perfectly fine. So if I were to look at it, it's a little more complicated. I have 4 breaks down into 2 and 2. 6 breaks down into 2 and 3. And 3 is just 3. So I'm circling those because they're prime. So I'm breaking them into their factors. So when I'm looking then, I say, okay, I have a pair. Anything that's in common, I could cross off and write it. I have a pair of 2s. I cross that and write it down. I have a pair of 3s. I cross that and write it down. And then I have this 2 that's left over. Well, what's 2 times 3 times 2? 12. Could you have figured that out maybe by just looking at those numbers? Sure, that's possible, and that's okay. Just double check it. 12 divided by 4. Yep, whole number. 12 divided by 6, whole number. 12 divided by 3, whole number. 12 divided by 4, we just checked. So that means that's what I have to multiply everything by. Okay? So 12 times 3/4. Some of you may choose to just put that in your calculator. Draw that down again. That is perfectly fine as well. Some of you may say, well, could I do 12 divided by 4 is 3? And then say 3 times 3 is 9x? Absolutely. Okay. Here, could you do top? 12 times 1 is 12 divided by 6 is 2. Yep. My equal sign. 12 times 2 is 24 divided by 3 is 8. That has an x on it. Here I'd have 12 over 4 is 3. Again, an equation with no fraction. That's our goal. For most of you, you might think like, oh, I got to do that first. Yeah, but it works better than you working with fractions. Okay. All right, now I have variables on both sides. I'm moving the smaller of the two, positive 8x. I move by subtracting 8x. So here I get 1x minus 2 equals 3. Want to isolate that x. I add 2 to both sides. Now, do I need 1x? Not really. I could just write it as x equals 5. What if you wrote 1x? That's okay. Some of you are in the habit of that, and you just say, okay, I got to get rid of it. It's multiplied. I divide by 1. X is equal to 5. Okay? So, have the pen. You're rocking it right now. If you have more questions in class, that's the time to let me know. So, just like the other day, make sure you finish those notes up with this. Keep being awesome. We're going to get through this and figure it out. I know it's a little bit different right now, but we'll continue to adjust and make things the best we possibly can. So use those notes. Use those 5 steps I gave you the other day. Keep working hard.